So today we're going to learn about testing your code. Okay. So why do we need to do testing? Because we want to make our software much more mature and free of errors. So to increase the customer satisfaction as well, and customers will pay for your software only when it is of high quality. Okay. And most of the companies have very tough procedures where they check for the quality, the regression, and all that parameters. Then only it will be sent to customers. So as a developer, you are definitely asked to do some kind of testing for your code, whatever you written, either a function or either a API, or you written a whole tool. So you need to write basically tests. So there are basically two types of tests. One is called integration tests, that basically checks all of the components which are there in your application and they interact with each other, right? It will test the whole integration itself. Whereas there is one more type of test called unit test. Okay, so unit test is basically, it will check for only some of the functionality, a very small component in your application, and you are responsible for it. For example, assume you have written a function called sum. Okay, so by default in Python there is a inbuilt function called sum. Okay, so it is very easy to test in Python such kind of application. So let us see here. So let me go to Python here, and by default in Python there is a statement called assert. Okay, so I want to assert whether 1 is equal to 1. So it will say true. Didn't give any error. But if I say 1 double equal to 2, the assertion error, you will get it. Okay, so the most basic way of testing something for possibility of true or false is that you use directly assert statement in Python. Okay, so now I want to test the Python sum function which is there by default, and say for example whatever I pass to the sum, and I want to test whether it is equal to 5 or 6. So if you count this 3 plus 2 plus 5 plus 1 6, so I'm assuming that the output should be 6. So I'm testing for it. So I created a function called test sum, and I'm just calling it. So instead of writing like this, assert 1 double equal to 2, which I can directly do it, but I want to pass some arguments at a later point. Okay, so I'm going to pass this, I'm going to call it. Now let me run this and show you. This is a very basic way of testing some function that you have written. So Python intro.py. Okay, so everything passed is the output. But what if I make it equal to 5? If I make it equal to 5, it throws an error. Okay, so it is assertion error. You saw a similar error before. Okay, it's very simple, and this is how you do a basic testing. Okay, now the problem is you can't keep writing hazard statements. You want to do something more powerful. Okay, so that is why Python gives you three packages to do testing. So the first package is unit test, which is by default, which has come from Python 2.1, which is already there by default for you to do testing. Okay, now there is also an additional package called nose, which you need to basically install, as well as the PyTest. So PyTest is much more powerful among all these three, and many people use it. Okay, so now I will talk about unit testing the code. Okay, so basically, as you learned in object-oriented programming language, right? So unit test is basically object-oriented code. So you to write unit testing, you need to create a class. Okay, so that is the first criteria. You have to put all your tests inside the class. And the second thing that you need to do is that there is already, like, you saw only one assert statement, right? So there can be assert, you want to do testing in terms of equality, you want to do testing in terms of some other things, right? So all that is provided in unit test package itself. So let us try to convert the same function. Okay, whatever we wrote so far, we will try to put it in a class, and we will try to make it uh, equivalent to a unit test case. So now to do that, as I said, I will import this unit test module. That is the first thing I need to do, which is inbuilt. So you don't have to do any installation using pip. Okay, just do import unit test. Now, as I said, I need to create a class. Okay, for what are we testing here? We are testing for some functionality which is inbuilt. Okay, I can name it anything, but I'm generally all the classes start with capital letter, and this is the test. And one thing that you need to keep in mind is that it inherits all the classes where you want to write test cases need to inherit from a unit test class called unit test dot test case. Okay, and I will not do anything here. I will just put it inside this particular class. And as I understood, and you already know that all the methods inside it, most of these are called instance methods. So I need to add self to it. Now this function will not run. Okay, so basically instead of using this, I will just remove this. I will also remove this. Okay, the way to call this testing functionality is basically unit test dot. Okay, you need to do basically main. So what I'm doing here, I just converted my previous code into a very simple thing, but instead of using assert, as I said, this particular unit test gives you a lot more flexibility in terms of testing. So I can do this self dot assert equal. Okay, and I want to do testing for equal, so I don't have to put, just pass the values to it, and it should give you whether it is right or wrong. Okay, so now let us try to run this python intro.py. Now you saw the output in a very different way. This is a typical python output, but here it will give you more information. There is an output called f here. That means the test case failed. And what is the failed test case? Test underscore sum. Okay, and it is saying that the assert is not correct. Okay, because you are asking for some of this is 6, but you are checking for 5, so it became an error. So now I'll try to make it 6. Now let us see what happens. So now it is saying dot here, that means it passed, and it is saying ran one test and it is okay. So this is how you write a basic unit test for your code. Okay. Now we were testing for inbuilt sum function. Okay. We were writing some code for inbuilt. Okay. Now what we will do is we will write our own sum functionality. Okay. And we will try to do a simple things. So let us try to do our own sum functionality, but I will call this module called custom.py. Okay, I created a file called custom.py. Custom.py is a file which is a module where I will write my actual code. Okay, I will not write test cases here. So in this, I will create a sum function. For example, the sum, it should take any number of arguments, like you know. So I will define a variable called total to calculate the sum. So I will say for item in args, for num in args, maybe assume it. And what should happen here? Total should be equal to total plus num, right? That's the value it should return, right? So let me return total at the end of it. So this is a very basic functionality. If you want to just try it out, I will just say if name is equal to main, I will just call this sum functionality with a list 1 comma 2 comma 3. Okay, now let me run this python custom.py. So it is giving me what? Sorry, I should not pass in a list. I just pass the arguments like. Okay, so now I'm not printing it, so it is not printing anything, but let me print it. So the output of this particular function is 6. Okay, so this is a file where we have written actual code. Now what we want to do is we want to test this functionality. So for that, I will go into testing intro.py, And instead of calling this sum function directly here, I'm not going to make any change here. Let me make this different name so that you don't get confused. Some numbers. Okay, some numbers. And what I will do is, from, I have to import this, right? Import custom, and custom is a module name. Now how do I call that function here? Custom dot some numbers, and I need to pass the arguments. Now it will tell me whether this particular thing ran or successfully or not. So it is saying that it is correct, right? So now I can do much more. I can pass any number of arguments, right? Similarly, I can write one more test. Okay, def test underscore raise error. Okay, I want to do self assert raises exception. One second. The syntax is that you call the it has to raise an exception basically. Just a minute, I will show you. Before that, not to make it very complicated. So basically there are two types of test cases. One is called positive testing. Whatever we are doing is positive testing. We are testing for the output of the functionality, and we are testing whether that is equal to or not. And there is other way of doing the test cases. This is called happy path. Wherever we pass, it is performing correctly. But in a negative case, we try to pass something which will create a problem for our functionality. For example, assert equal, okay, and custom dot some numbers. What if I pass a string here, test 1 comma 2, and I am assuming the output should be 6, and it will throw an error because uh, it is assuming that the output should be something, but it is not. I will remove this so that not confuse you here. So out of two test cases, one test case passed and one test case failed. It is saying that the test sum object has no attribute assert equal. Okay. So test underscore raise error. Now this number is throwing me an error. So let me try to do something else here. Let us see. 4, 5, 7. So will this become successful? Still it is giving me an error. So there is something else that is problem. Just a minute. Let me see what is the problem here. What is the error here? The test sum object has, so I am doing something wrong here. I just said assert, I'm missing T there. Yeah, so now two tests passed and one, like both the tests passed. But what if I pass something else which is not required by the function? So it should basically, one test should fail. It should say that unsupported operand type between int and string, because we were expecting only numbers and now it is also expecting a string. We are sending a string, so it will fail. So this is how you basically test. But the test itself should not fail, right? It should say, okay, I've tested for an error, but it should say that, okay, you already tested for this error. It should raise that. The expectation from that code is that it should raise an error. Okay. So now before I go forward, any questions?
Pawan, just one of this. So we are expecting errors. Is there any way to handle this error? Like I am expecting an error, but I don't
Yeah.
want this test to be failed.
Yeah. So that's what I'm telling you now. So I know that the expectation from my functionality is that, it should raise an error, and I'm going to test. That is called negative testing. So how to do that? Okay. It's very simple. What I will do is, I know that self assert raises is some kind of functionality, and what kind of error it should raise. For example, I will assume it should raise an normal exception, and I will do this. Okay. Now, if you run this code, it will say there are two test cases that ran, and both of these test cases ran successfully. So with this kind of testing, like assume you're doing, you want to test whether the code that is there in this block with the block raises an exception called exception. Okay, so that is what you are testing here. So we tested on positive case, we also tested one negative case. The way to do negative testing, for example, you want to check whether it raises an exception. So basically you would do a say with self dot as it raises, and whatever you want to test, whichever exception, and you do self dot assert equal. So similar to this, you will write, for example, if you have your own module, you will write like, multiple test cases like 20, 30, 50. The whole point of, uh, running this kind of code is to understand, does your code, does your tests cover all the logic that is built into your code. For example, you written a function, right? So our actual enterprise code will not be this small, it will be very big, right? So you want to know whether whatever test cases you have written, it has reached all the lines in the code or not. That is called coverage. So most of the time, in the companies, they expect you to have a coverage of around at least 90%. That means 90% of the code is tested properly. So that is the meaning of coverage. And there is some good Python packages to do a coverage. You need to know what is the coverage of this particular code, so you will get a coverage report. And it is quite interesting. And the other way to run this particular test cases is basically Python. uh, what will you say is, you will give a module name, that is you are using unit tests. And uh, basically if you run this, what happens is that it will try to find out test cases in your current folder. But right now there are no folders. So by default, unit test tries to do something known as discovery. So it goes into folders and try to find out classes which are inherited from unit test or test case, and tries to find out the test cases. Okay. So that is called discoverability, and all these frameworks have that discoverability functionality. And where are my test cases? Basically now they are in the intro, right? So now when I gave my module name where I have written test cases, so it basically ran two test cases and it gave me whether it was success or failure. So this is called unit testing. Okay. So for example, in the integration testing, suppose you want to do integration testing, right? So in integration testing is basically what you will do. You will call some of the others API. You will call, you will run some command and it gives success or failure. All that thing can be done as part of the integration testing, and PyTest and unit test provides you with capability to do that. Okay. Now, how to know what all the test cases that have been discovered? So, for example, uh, just a minute, discover. Just a minute. Sorry, I need to give my directory. So it's not able to discover here. So it should give me kind of the folder name. Okay, it will tell you what all tests are present in that particular location. So whatever the unit test is trying to discover, this is how you give Python -m and you say discover. Okay, Python -m unit test and you say discover, and whatever folder name that you give. So right now it's not able to discover anything by default. Now this is about unit testing, and you write a lot of unit tests. Okay, and in all of these unit test cases, right? So basically you would have something known as a setup, and you would have something known as a teardown. Okay, for running any of the test cases, you need some data in the database. You want to create some files before you want to do some kind of testing. You want to create some kind of temporary data for your test case to run successfully. Okay, to do that, basically what you do is every unit test cases, right? So you can write one function here called setup. I will create it dev. So I will say setup. Okay. Um, I'm just taking it. I'll just make it cell, and you will do print. I'm for test cases. I'm just trying to give you some example here. Setting up test environment. Okay. Now if I run, will it print? Will it print? Let us. So see, before running any test, it is trying to run this particular setup method. That is the meaning of basically setup method. So whatever you require, you need to do using the setup method before. And also there is a method called teardown that people use to do tearing down the whole environment once your test cases have been run. So there are a lot of test cases that people write. Sometimes, not only the test case that you write in the code base for the code base, you also do security testing. You also do a lot of, linting that is called, you want to test whether there were specific, some spaces are left or not for indentation. Is it following Python standard of code or not? All that can be checked. And this all, everything will run as part of a pipeline um, in the in the production environments before we push. So any questions in this testing? So let's try to do sorry, questions also. Let's try to test whether google.com is working or not. Okay, let's try to do that. So let me install a module called requests. So request is a library in Python uh, which helps you to connect to some of the services are which are running on the internet. Okay, and test whether it is working fine or not. Like you can test all that using this particular package. So I want to say test underscore Google. Okay, now what I will do is I will make request dot uh, let's try to see why this is not coming. So I created this request.get, and I will store this in a variable called response. And I want to assert self.assert equal. I want to say whether the status code was returned as 200. So let me try with 300 first. Let's see whether it gives an error. Python intro.py. So it says ran three tests, but it failed. One failed because it is trying to test for 200, but you are testing it for 300. The actual response is 200, but you are testing it for 300. So let us try to do with 200 now. Now the test cases actually should pass. So this is one of the ways to do integration testing, right? You interact with the third party system and try to see whether the response or the code is correct or not. Okay. So the request module in Python is a library which will help you to connect with the internet services. So this will take one URL. You want to do some authentication and all that you can do. But here I'm just calling google.com, and I'm just checking whether whatever has written it is equal to 200 or not. So what is 200? 200 is a HTTP status code, which means success. Okay. So this is all about unit testing. So if you want to do something little more complex, you can use mocking, you can use PyTest, all this. You can, there is a concept called fixtures. That means, you want to set up some data, right? So you can use an additional function, which you can call it a fixture. And you can actually, it will be available as a variable to you, and you can use that and do something with it. Yeah, I think that's about the unit test.